So hi guys, I'm going to talk to you about artificial intelligence on Spring, and more specifically planning optimization, which is a subsection of artificial intelligence. Now, planning optimization is probably one of the most profitable or impactful things we can do with AI. Well, it doesn't belong to the neural net side. It's not things where it's not pattern recognition, voice recognition, or image recognition, but it is still very much AI, and I'm going to show you to that today. So I'm Geoffrey the Smet, I'm the OptaPlanner lead, and I'm not related to Hannibal J. Smith, but I do love it when an OptaPlan comes together, right? So here's the application I'll be building for you today. So basically, it's a simple timetabling application, just to give you an idea on how you can build your own planning application. And in that, we'll be assigning lessons like the English lesson, the chemistry lesson, and the math lesson, as you can see here, to time slots, such as Monday at 8:30, and to rooms, such as room A and room B, and so forth. And we'll have a solve button there, and that's when when you click the green button there, that's when the AI algorithms do their work. Now, just to give you an idea on what's the input and the output of the application that I'll be writing for you today. So we have a number of lessons, as you can see here. Again, 4 lessons. We have a number of rooms and time slots. We have some slots where we can put those 4 lessons in. And we have a number of constraints. So what are constraints? There are things we cannot do in our planning. So for example, we can only put one lesson in one room at one time at the same time. So we cannot say math and chemistry, let's both put them in room A at the same time, right? Other constraints are, for example, when 2 lessons share the same group of students, like math and chemistry, they are both shared by the 9th grade, we cannot put them in the same time slot. So we need to make sure that these 2 lessons, the green and the yellow one, do not occur at the same time. Same for the French and history lesson. They are both followed by the 10th grade. Let's presume there's only one 10th grade class here. It's a very simple case. We want to make sure that those don't occur at the same time. Now, as you can see, chemistry and French are attended by different student groups, but they are they are taught by the same teacher, by Marie Curie. So we want to make sure that chemistry and French also do not occur at the same time. So what we're going to do is, with our Spring Boot application, we're going to give this to OptaPlanner, and OptaPlanner will give us a solution. And this might be, for example, a solution. And as you can see, the 9th grade doesn't have 2 lessons at the same time. The 10th grade doesn't either. And Marie can also do both of her lessons without splitting herself in 2, right? So that's what we're going for. That's the case we're going to solve today. Now, the interesting thing is, this is just one planning problem, right? And what you'll learn here will apply to many other planning problems too. And that's the thing to keep in mind during this session. So, for example, you can do equipment scheduling with it. So scheduling of hospital beds or CAT scanners or rental cars. So anything that is reserved for a number of days, and you want to make sure that you want to increase utilization by scheduling that equipment as efficiently as possible. Another planning problem you might have, and you can solve it with what you'll learn today, is, for example, job shop scheduling, in where you have an assembly line where you're building cars or books or furniture, and you want to reduce the make span, the amount of time it takes to actually build those things. Now, the interesting thing about that is that when you build a car with a sunroof, you shouldn't have 3 cars that need a sunroof all after each other on the car belt. But on the other hand, you have constraints like when you need to paint the car red, you want to have as many red cars after each other on the assembly line. So again, those constraints play into account to make it more difficult to reduce that make span. Now, one of or actually the most interesting case, I would argue, is the vehicle routing case, in which we need to deliver or visit a number of locations across the country, and we want to do that as efficiently as possible. So, for example, the yellow vehicle over here stops at these dots, as you can see, and the purple one stops at those dots. Now, this applies to last mile delivery or any kind of transportation cases, but it also applies to technicians on the road. For example, to install telco at people's homes or to fix people's dishwashers and stuff like that, right? And the interesting thing is, when you do this, we have actually applied this in some cases up to multiple tens of thousands of vehicles. And what we saw is we saw a reduction of driving time of 25%. 25% reduction of driving time for a fleet of 10,000 of vehicles translates into hundreds of millions of dollars per year savings. It also translates into tens of millions of kilograms of CO2 reductions of due to the fuel emissions. So it's good for the environment and it's good financially, right? So there's great potential in that one. Then another one is bin packing, for example, assigning processes on the cloud as efficiently as possible to increase, again, utilization of these machines. And one of my favorites is employee rostering, where we're trying to increase the health and the happiness of the employees by making sure that that when we assign them shifts, for example, nurses or doctors or security guards and so forth, that we make sure that when they want a free day, that they get that free day, right? When they don't like to work afternoons, we try to give them more mornings and things like that. But also take into account all labor regulations, health regulations, for example, that they have enough sleep between two shifts and things like that. This got really interesting lately, of course, due to the global crisis, and these actually add extra constraints. For example, certain shifts in certain hospitals should not be given when, for example, in a COVID ward, to people who have a high risk of when they get COVID, for example, based on their comorbidities or age or things like, or any function of that. And of course, the interesting thing is with OptaPlanner we can add such constraints, right? So I was going to try to build an application. So normally I build an application from scratch. Given the time limits, this is a more TLDR session. This is a good thing, of course. I'm going to fast forward a little bit, and I'm going to show you what I've already built, and I'm going to continue on that, adding in OptaPlanner on the existing Spring Boot application. So I have a Spring Boot application. And in the Spring Boot application, I added Spring Web to expose a REST service. I added a simple JavaScript UI, which you'll see in a minute, which is to show those, which I already saw a screenshot of, right? And I'm communicating through that through JSON, plain old Jackson. And of course, I'm using Spring Data to go to a relational database through Hibernate to store that into an H2 in-memory database, right? So this is what's there already, and I'm just going to show you that right now. So there's no AI in there whatsoever yet. So let's take a look what we have here. So I generated this with start.spring.io. I have the typical dependencies, web, as I told you, the data JPA to go to the database, and I'm exposing all the REST repositories automatically, all the data repositories automatically through REST interfaces and H2 at runtime. Besides that, I have a few more JavaScripts for the UI, a couple of web jars to make the UI pretty, but that's not important, as we'll only care about the backend today. Okay, so what do I have in here? Let's take a look. So we have the Spring Boot application, the typical one with Spring Boot annotation over there. I'm going to add some test data, as you can see here, a couple of time slots. I'll go into the time slots in a minute, but I'm adding 10 time slots, the 3 rooms, and a bunch of lessons, right? So let's take a look at the domain, right? And this is, of course, a crucial part to understand. What's the domain? What's what we're going to solve? So we have a time slot, which has a day of week, like Monday, Tuesday, Wednesday, and so forth, which has a start time, for example, 9:30, and which has an end time, for example, 10:30, right? So that's its time slot, and that's during that time we can do 1 or more lessons, as long as they're not in the same room, of course, right? Then we have a room. We're going to keep it simple. It simply has a name: room A, room B, room C, and so forth. On top of that, of course, we have the lesson. And what is a lesson? It is a subject, such as math, French, chemistry, right? A teacher, such as Alan Turing, Marie Curie, and so forth, and a group of students, such as the 9th grade, the 10th grade, and so forth. As you can see, I've keep it very simple here. I've just used strings to represent those 3 things, but of course, in a more elaborate example, you'd actually have a subject class, a teacher class, and so forth. Okay. These lessons need to be assigned to a time slot and to a room. So each lesson has 1 time slot and has 1 room, or will end up with 1 time slot and 1 room, because when we start out, before we use our AI algorithms, they will not be assigned, and we'll use the OptaPlanner AI to actually make sure that those get assigned. The other way around, of course, a room can have multiple lessons, just not at the same time, just one after each other, right? So that's a one-to-many relationship or many-to-one, depending on how you look at it. Okay, so let's take a look at that in the code. So in the code, we have our room class, Of course, some annotations here to put it into the database. I'm going to ignore these for now, right? The string name is the most important thing here, the ID for the database again. Then a couple of constructors and then toString and some getters and setters to make it all usable. Of course, you could do this in Kotlin too, and this would be less code. I personally prefer, well, I'm more comfortable in Java, so I'm going to do this in Java today. So I'm going to go to a time slot. In the time slot, same thing, some annotations for JPA to put it in the database and the ID, and then the three things that matter: the day of week, which is of course Java time. You should only be using Java time when you deal with time, and not Java util date, and of course start time and end time, again a local time here. In more elaborate examples, this might be an offset time or a zone time, but this one will just presume that everything is happening in one time zone. Okay, then the most interesting part is of course the lesson. In the lesson, we have our subject, our teacher, and our student group as strings, and we'll need to assign them to a time slot in a room. So you can see when we create the test data with the this constructor over here, they get assigned to a subject and to a teacher and to the student group, but there is no time slot in the room. So those will start up as NULL, right? So now we need to be able to bring all of this to the UI, of course. And because we have multiple lessons, multiple rooms, and multiple time slots, we need to have a wrapper object. And that's actually the timetable, right? So this is the one JSON object we send from the backend to the front end. And it has a list of all the time slots, a list of all the rooms, and a list of all the lessons. And again, some getters and setters and some extra constructors there. So let's take a look at how that looks on the UI side. I'm going to go to localhost here. Oh yeah, I'll better first start running it. So let me open my terminal. No, let me just do run the Spring Boot app here. All right. So, and while that starts up, I'm of course exposing this timetable to a timetable controller, which for now is a simple listening to the timetable and gives us the timetable, right? And so that's the timetable repository. I'll show that. Let me just show that as a find method. So in this find method, what we're doing is we're taking all of the time slots, all of the rooms, and all of the lessons from our repositories, plain old simple Spring repositories. We're collecting these all into a timetable object, so that doesn't actually exist in the database, the timetable object, and we are sending that back. So this is transactional, and we're sending that back to the controller, who's sending it back to the UI on this REST URL. Okay, like I said, the repositories are pretty simple. It's a typical paging and sorting repository, and the find-all method that I've added, so I can use it in the timetable repository. Okay, let's take a look at what that gives us on the front end. So if we do a refresh here, you can see we have the unassigned lessons at the top, at the bottom. Those are all those I added in the Spring Boot application. Let me just show you here. So those are all the ones that I added here, right? In the command line runner to add the demo data, right? So it's just chemistry, math, biology. You can see those over here too, chemistry over here, and so forth. And of course, we have our rooms and our time slots. And now just one simple thing left to do is pick which time slot, which lesson goes into which of these cells, right? And that's actually not as simple as you might think. I'll show that in a minute. But okay, let's press the solve button. What do we get? The solve is not yet implemented. Why not? Because when we go back here, go back to our controller, and let me just show this a little bit. When we hit that endpoint, there's a throw no unsupported operation exception, right? So this is the part that we now need to start implementing. So it's time to start coding, and let's add that. Okay. So what I'm going to do is, let me just switch back to my slides. I'm going to add OptaPlanner. So what I'm going to do is take this application and simply add the OptaPlanner Spring Boot starter in there. And let's do that right now. So I'm going to go to the POM file. I'm using Maven today. Of course, you can do this with Gradle too. Yeah, this is, of course, this solve that we called, nothing special in that stack trace there. And what I'm going to do is here in the Spring Boot starters, I'm simply going to add, maybe over here, I'm going to add a dependency. I'm going to use OptaPlanner Spring Boot starter. Here we go. And I'm going to use the latest version, right? So simply adding the OptaPlanner Spring Boot starter. This is IntelliJ, so I'm just going to import the new things, and I should now have access to everything in there. So the next thing we need to do is we need to tell OptaPlanner what it can change for us. So if you go back to our slides, remember this is our domain objects, right? Remember our lessons need to be assigned to a time slot and a room. So these are the things that start out as NULL. Well, we need to tell OptaPlanner that it cannot change the subject or the teacher. Well, we just need to tell him what he can change. So we need to tell OptaPlanner here, those orange things, the time slot and the room, those are the things you can change. Right? Those are planning variables. Those are variable during planning, during solving, right? And because of these two properties, they are in the lesson class, then the lesson class needs a planning entity annotation. That's basically a way of saying there's some planning variables in this class. Please pick those up and use those. Okay, so the time slot and room field starts null before we solve it. Then we give it to OptaPlanner. When it comes back, these time slots and these rooms will be assigned. Now it's just not one lesson that's being assigned, but all of the 20, 25, or 30 lessons we have in this case, and it's going to make sure that they're assigned such that they are not in conflict with any of the other lessons, right? So that's the difficult part, right? Okay, so let's take a look at actually doing that. So we're going to go to the lesson class. So, as I mentioned to you earlier, we need to add a planning entity over here. So now OptaPlanner knows there's something in here that I can change, and now we need to tell him what exactly he can change. Well, that's the time slot thing, of course. So we're going to say this is a planning variable. You can now change that. Now, one of the things is OptaPlanner needs to know, okay, I can change the time slots, but which time slots can I put in there, right? Let's say I have a couple of lessons. I take for the first lesson, the math lesson. Which time can I create time slots out of the blue? No, that's not true. You need to pick one of the time slots that's available, like for example, Monday 8:30. So we need to give him a list, a collection, or a range of time slots. So, and this is called a value range. And this is with a ref. So I'm going to say, I need you to take the time slot range. And somewhere else, we're going to actually hook in this ID where we have the actual list of time slots. I'll show you that in a minute. Same thing for room. This can change during planning. So this is something that OptaPlan needs to sign for us. And in the same case, we'll have to give him a list of all rooms. So let me just call this the room range. Okay, that looks fine. So that now OptaPlan can actually start assigning those, but it cannot solve just one lesson. It needs to get all of the lessons in one package, right? It needs to solve one problem. And that's a timetable. So that's the planning problem that OptaPlan will solve, but because here it has all the lessons. And when it solves it, when it returns, it will return again a timetable which contains, for example, all of the lessons, right? And you might actually have multiple planning entity classes, and in which case this becomes a bit more complex. But anyway, so this is something that will also be a solution once it's solved. So I'm going to, for OptaPlanner to know that this is basically our data set, right? And this is a solution once we solve it. It's called a planning solution. You'll actually see multiple of these because OptaPlanner will find better and better solutions and will give them back as timetable instances for you. So it needs to know, here's that property that contains all my planning entity, or at least here's one of those properties. So we just need to say, this is a planning entity collection property, right? And then now OptaPlanner knows when he gets a times table, here I can find all my lessons and I can start assigning these. Now, the problem, of course, is we need to give him all of the a list of all the time slots to pick from. So that's this time slot list already. We seem to have it already. So let's just add that. This is a value range provider, and I'm going to just call it, so the ID is that time slot range, right? Similar for the room range, I'm going to just say, look, this is the room range. Okay, looks good. One more thing, once we solve this with OptaPlanner, OptaPlanner will actually give this a grade, a score, to tell you how good this solution is. And he wants to actually add it into the planning solution. So I'm going to add a score here. This is a hard soft score, which means it will tell us how many times the hard constraint is broken and how many times the soft constraint is broken. Of course, we're going to try to get the best possible score. Again, for OptaPlanner to pick this up, you want to add a planning score annotation there. Okay, this looks good. Let's actually hook this up into our controller. So when we have the solve method here, we need to now call something to solve. So OptaPlanner can, through the Spring Boot starter can actually auto-wire a solver manager for us. So a solver manager is like an entity manager, but then for AI planning problems. And it is a little bit generic. So I can say, I'm going to give it a timetable and it will solve that for me. So this is our solver manager. And more specifically, it can handle multiple tenants and those can have a job ID. So that's I'm going to use long as job IDs. You might want to use UUIDs, that works too. So what I'm going to do here is I'm going to say, when you call the solve method, I am going to solve and listen. So what does that mean? I'm going to solve a problem, right? And when that problem is, every time we find a new, better solution to that problem, and a solution where we have a higher score, right? We're going to store that into the database so we can actually see the progress as OptaPlanner finds better and better solutions, and we can show that into the UI. So the first thing I need here, I need to give it a job ID. So I'm going to keep that simple, just one. Now I need to give him a function where I can load the data set, right? So I'm just going to load the data set directly from the timetable repository. I'm going to use the find there. So given a job ID, actually problem ID is the right word. I'm going to say here, just find that. Now the last thing, when I actually find a new, better solution, I'm going to need to store that. So I'm going to say the timetable solution, please save that into the database. So I'm going to, and here I can just directly wire in that thing. So let's take a look there. So when we go into the save method, what actually will happen is it will take the timetable, will go through all of the lessons and save those lessons, right? So as OptaPlanner assigned both the time slots and the room to actually save that into the database, which will allow our UI, which is just polling, to actually show that results. One more thing we need to do is we need to add a constraint provider. That's actually telling them what OptaPlanner needs to know, what is better and what is worse. So for now, I'm just going to throw in a dummy one. I'm going to call this a timetable constraint provider. All right, I'm going to implement constraint provider. And I'm just going to do that dummy wise, and here return a new constraint. Here we go. All right. So no constraints so far at this moment, right? Okay. So let's take a look when what happens when we run this. So we can just do rerun our application. Let's see if that actually boots up, if you don't get any exceptions. If there's something wrong, OptaPlanner will fail fast. For example, if I misspelled room range or something like that, but nothing went wrong. So we can now solve this. We can now go over here, we'll refresh. We can press the solve button. Let's see if OptaPlanner starts actually assigning those lessons. Remember, we don't have any constraints so far. We've not said what it cannot do. So when we do this, what happens, OptaPlanner assigns all of the lessons into the first room, into this first time slot. So we're, this is not a feasible schedule, right? This is breaking a lot of hard constraints, namely that all of the lessons, are in the same room at the same time. So let's fix that. Let's go back to our constraints over here. And let's actually add a room conflict because constraints. So we're going to add a room conflict constraint with the constraint factory here. I'm going to just add that method, right? Now you could write that with a bunch of for loops, but I'm going to use a technique which is far more scalable because it does incremental calculation. And it's an API that's very similar to SQL. So think SQL when you read this, right? So what I'm going to do is I'm going to say I'm going to select a lesson, right? And when I then join that with another lesson, so I have two lessons which are in the same room at the same time, then I'm going to penalize that as a room conflict. This is a hard, it's something that really should never happen. So it's a hard score. So I'm going to add this as a hard soft score. If it's something that is allowed to happen, but we want to minimize that, we would say one soft, right? Now, these are just any two lessons. We need to actually have two lessons that are in the same room at the same time. So we need to say, okay, these are, I mean, to join them on an equality, and we need to say these are two lessons that are in the same time slot, right? And also they are at the same time, in the same room, right? So 2 lessons in the same room at the same time, right? Okay, let's take a look what that gives for us. Let's run that. Okay, we run that, we switch back to over here, we refresh, we wait a few seconds for the server to start up. Here we go, just one more, here we go, and we click the solve button. And what happened now? Now all of the lessons are assigned to their own room in their own time. So we don't have any room conflicts anymore. And this is pretty simple to do as a human yourself, right? You could easily do this yourself. You just pick one and put one in each time slot. However, this is not a feasible schedule because if you look at it from the teacher's point of view, we're asking Alan Turing to be in to teach 2 lessons at the same time, right? The 9th and the 10th grade in the same room at the same time. So that's a bad idea, right? So let's go back to our code. Let's fix this step 2. So I'm just going to duplicate the other one. I'm just going to say I want to have a teacher conflict, right? And I'm just going to duplicate this constraint here. Say this is now a teacher conflict. And I'm going to say, okay, when we have 2 lessons in the same time slot and the same teacher, then we are asking a teacher to be in 2 places at the same time. And of course, that's a bad idea. We don't want that. Notice that these 2 constraints are isolated from each other. So if we enable or disable one, or we refactor this across when we have dozens of these kinds of constraints, we can just focus on one at a time. And that's really nice, of course, right? Okay, let's take a look what that gives us. Let's click the solve button. We can see we have them by room. We look at per teacher, we can see we're not asking a teacher to be in 2 places at the same time. However, when we look at the student groups, we're asking certain student groups to be in 2 places at the same time. So same logic, we again go back. This is getting a bit repetitive, of course, but we're saying, okay, for the student group, I want to make sure that when I have a group of students, that if they have 2 lessons at the same time, that is not, that we cannot allow that. So in here, of course, we say equality on the student group. And these are all hard constraints, right? Now let's go back for a second, see how this refreshes. I can see that if we now press the solve button, that the algorithm automatically adjusted itself. So here again, all of the rooms, we only have 1 lesson in 1 room at the same time. We have, this is the teacher's view, right? No teacher has to be in 2 places at the same time, and the same for the students. Now, coming up with this schedule as a human is already quite difficult. It's actually already quite difficult, and it's a feasible schedule, something you can actually put into production. However, it's not a great schedule. So if I had more time, I'll actually show you, but what we can easily do is we can add these, we can, for example, ask OptaPlanner to not have these gap hours, and then it would automatically push those lessons together, right? So that would be a soft constraint, basically telling, for the sake of the teachers, make sure that when they have to come to school, they don't lose any hours in between lessons, right? It's just 1 big chunk of lessons in one time, or even avoid spreading it across 2 days and stuff like that. And of course, OptaPlanner would automatically adjust to that. Even one interesting one I've actually seen these days. So when we talked about hard and soft constraints. So hard constraints must not be broken. Soft constraints should avoid being broken. Another one is when in this COVID-19 era is when we want to do school timetabling, and we want to make sure that the students in the hallways flow from left to right. So flow from room A to room B to room C, but never go from room C to room A unless there's a break in between. And that's a pretty easy constraint to add too. So let me just quickly show this one as this constraint. So add that. And you can actually see that if you look at the solution now, it's being violated. So if you look here, the 9th grade is going from room B to room A at the 9:30, and there's no break between there. So if we go back to our constraints here, we throw in this constraint. I'm going to not explain it now due to just to go to do this quickly. And you will now see that if we refresh this, right? And remember, we saw 9 grades in our previous solution going from room B to room A at the 9:30 segue. And we can now see that it's no longer happening. In fact, apparently it's putting all of the lessons in the same room right now. It's keeping it simple. Once we add in more of the other soft constraints, that won't be a good possibility anymore, because you can still see for the teachers there's still a lot of gaps, right? But we can have our cake and eat it too. We can add both of those constraints, both as soft, and they will be weighted against each other. And based on that, Opta will find a win-win situation for everybody, right? So if there's any questions on Discord, I'll happily answer them.
All right. Well, thank you very much, Geoffrey. So we have a couple of questions here.
Yeah.
The first one is, what is the range of algorithms that OptaPlan uses? The user is saying, I solved a timetable generation problem for a faculty with my own genetic algorithm.
Yeah. So OptaPlanner is using, I can show you that. OptaPlanner is using a bunch of local search algorithms, such as tabu search, similar annealing, and so forth. I have a good overview here in optimization algorithms. So over here, so these are the ones we have implemented. Of course, brute force, branch, and bounds. Those don't scale. They're not really that useful. A bunch of constraint heuristics to get a greedy, easy, quick solution quickly, such as first fit decreasing, cheapest insertion, and stuff like that. And then a bunch of meta heuristics, such as local searches, tabu search, similar needing, and late acceptance. Actually, tabu search and late acceptance, those are and similar needing at times are really the best of the best algorithms. We have a bunch of others too. We've done a bunch of experiments with genetic algorithms, and I'm following up the research there as well as the academic challenges around that. Genetic algorithms sound cool. They have a really cool way of doing things. They're not performing in reality against the others, as far as I'm following the research and as far as I'm seeing for these kinds of cases. Genetic algorithms do have appliances on other kinds of cases for which which fall out of this typical planning problems, right? So use the right tool for the right job. For example, some people are trying machine learning algorithms on this, more particularly neural nets on these kinds of use cases. They reduce the driving time by 1 to 2% instead of 25%. So they get some results, but they're definitely they should stick to image recognition, voice recognition, all those wonderful things. The right tool for the right job. Don't use a screwdriver on a nail. Don't use a hammer on a screw. Right.
Right. Thank you. Another question: is it possible to modify constraints at runtime?
You could just create a new solver factory. So you could do that. Well, there's a couple of approaches. So first of all, if you're talking about changing the weights of the constraints or the data in the constraints, yes, we do that all the time. So it's a bit late to start the example now, but one of the things we can actually do is we can say for each of those constraints we have there, we can, for example, the COVID constraints, we could disable that. And we could disable that based upon something that's in the timetable. So in the timetable, we can say we want the COVID constraints on or off, and we want, if it's on, we want it to have it, a great importance or a low importance. And you can have the user in the UI actually play with those weights and those settings and those constraints and turn them on and off. Furthermore, many of the constraints you can declare generally. So for example, instead of saying a nurse can ask for a free day off on Friday, you can say a nurse can ask for any time off on any day for any period of length. And so you can make it very, very general. And that already allows you to do many constraints. However, very specific new constraints to turn, you can just reboot the solver factory, but that's a little bit more expensive. Yeah.
Okay. And just the last one real quick. Some attendees are kind of confused on where does OptaPlanner run? Does it run locally, in the cloud? So what is OptaPlanner?
It's an embedded Java jar, so you run it wherever you want to run it, where Java runs. But of course, it likes being run on the cloud, right? Because by default, OptaPlanner just uses one thread, one core, just to make sure it's easy for during development, so it doesn't eat your entire system. But you can actually give it more threads, and then it will do multi-thread solving. I kind of call that donating threads, because OptaPlanner likes one thing and one thing only. That's CPU power, right? So there's no I/O. Memory-wise, it's very low. but it will eat every millisecond of CPU you give it. So if you give it more threads than you have CPU cores, you will see that on your system. You will not be sharing with Zoom or something at the same time.
All right, great. Thank you for your presentation. People really enjoyed that. There are a couple of questions more on the Discord channel, so if you can jump into the Discord channel, that would be great. Yep. Right, and well, we'll just do just 2 minutes of break, because now we're going to go for the first quiz. So get ready for the quiz, right? And we'll be back in a couple of minutes.